As zoning rules relaxed, Mirpur Dos entered a period of rapid vertical growth. Traditional four-story homes are being redeveloped into dense, nine-story multifamily buildings. Building upward creates an immediate physical trade-off. You are placing more than double the number of residents under the exact same square footage of roof. For a neighborhood projecting up to 9,000 households, the old model of individual energy independence is broken. There simply isn't enough physical surface area to give every apartment its own isolated solar array. At the same time, the baseline energy requirements for these new high-rises are increasing. Building codes now mandate heavy loads like automated elevators, pressurized water pumps, and sewage treatment plants for the entire structure. The physical reality of vertical densification forces a shift in strategy. You can no longer solve the energy problem apartment by apartment. The building has to adopt a collective solution. Desco's escalating step tariff is a major threat. High baseline electricity pushes high-rise households into the highest tiers, costing 16.13 taka per kilowatt-hour. When the grid fails, buildings use diesel generators. With diesel at 115 taka per liter, these backups become a massive financial drain. Diesel generators come with a list of recurring costs. These industrial machines require expensive engine overhauls, filter replacements, and lubricants, all while generating intense noise and taking up premium parking space. This leaves residents with a difficult problem to solve: securing cheap, reliable backup power without injecting massive upfront capital or requiring inaccessible roof space. Relying on the status quo is a losing proposition. Residents are currently trapped between skyrocketing grid costs and economically ruinous diesel backups. There is a structural alternative to this cycle: the Virtual Power Plant, or VPP, aggregator model, utilizing a full system buyback package. The mechanism is straightforward. A building committee signs a tripartite agreement, leasing underutilized rooftop space to an aggregator. The aggregator takes the financial weight, installing premium solar panels and lithium-ion batteries. For residents, this requires zero capital expenditure. The trade-off for this free hardware is time and control. The building commits to a 20-year lease, relying entirely on the aggregator's centralized management platform. As part of this transition, the aggregator will actually purchase your building's existing depreciating diesel generator, injecting immediate cash back into the committee's reserves. By pooling their divided roof space, the community shifts the equipment risk, capital expenditure, and long-term maintenance burden over to a specialized third party. The most common resident question is about access. If the solar panels are locked on the 9th floor roof, how does a flat owner on the ground floor actually see a lower electricity bill? This diagram illustrates virtual net metering. Instead of complex internal wiring, the solar system exports surplus energy directly to the Desco grid. Encrypted advanced metering monitors this export, which Desco converts into financial credits, virtually credited to every participating apartment. Residents then purchase with daytime solar energy from the aggregator at a flat rate, guaranteed up to 30% below Desco's highest tier. When the grid goes down, the response is immediate and silent. The building instantly draws from the aggregator's fully charged battery blackout reservoir. Virtual net metering distributes power generated on the roof. Vertical density no longer prevents an individual flat owner from directly cutting their monthly utility costs. This table compares the models. Financially, the status quo demands huge generator costs and high grid rates, while VPP requires zero upfront and locks in discounts. Physically, noisy generators waste parking space, whereas the aggregator provides silent, zero-maintenance battery stacks. Evaluated side by side, the aggregator model systematically eliminates the financial and physical pain points of the traditional energy setup, without asking residents to spend personal capital. The government has also structured policy to encourage these systems. The 2025 National Budget Fiscal Policy introduced a critical new financial incentive. Residents who participate in a third-party solar agreement now automatically qualify for a 5% consumer tax rebate directly applied against their monthly solar electricity bill. Then there is the physical space you just got back. Removing a large diesel generator reclaims premium ground floor square footage, which can be repurposed for electric vehicle charging. With the generator gone, the aggregator can wire those newly freed parking bays for direct, solar-assisted DC fast charging, allowing residents to charge their EVs right at home without overloading the building's grid limit. The VPP model solves today's power shortages and provides the infrastructure residents will need to power electric vehicles in the coming years. By utilizing third-party capital and virtual tracking, the VPP aggregator organizes the neighborhood's fragmented rooftops into a unified energy network. For the budget-conscious flat owner, the outcome is clear. You secure immediate utility savings and collect monthly tax rebates, all without needing physical access to the roof. For the building committee, this removes the burden of property management. It eliminates maintenance tasks, collective funding disputes, and the liability of generator breakdowns. Finally, consider the new legal requirements. Under the 2025 Net Metering Guidelines, if your building requests a load increase to power new air conditioners or a larger elevator, you are legally mandated to install a solar system. The aggregator model is the only path that turns a mandatory government regulation from an out-of-pocket capital expense into a zero-cost utility upgrade. Speak to your Mirpur Dahus Porishore representative today to review the tripartite agreement.